Hello, my name is Sari Abelson, student physical therapist at Regis University. For my project, I evaluated force production of wrist flexors and extensors in various positions. As illustrated in the total length tension curve, maximum force production occurs at the resting length of a muscle due to optimal cross-bridge formation of actin and myosin protein filaments. I hypothesized that shortened and lengthened grip positions of the dynamometer would result in decreased force production as compared to a standard position. In standard position, the dynamometer was adjusted so proximal interphalangeal joints were in contact with the grip and metacarpophalangeal joints were in a neutral or slightly flexed position, with the elbow bent at 90 degrees and the arm 2 inches from the body. I also hypothesized reduced force production in the flexed and extended wrist position as compared to standard position without a flexed or extended wrist. I anticipated the greatest reduction in the flexed wrist position due to active insufficiency of the wrist flexors as they were maximally shortened in a closed fist and flexed wrist position. Subjects included 8 student physical therapists at Regis University, 37.5% male and 62.5% female, with a total mean age of 26.88 years. The subject maximally contracted for 3 to 5 minutes while squeezing the dynamometer, and the peak force in kilograms was obtained for each position. Mean and standard deviations were calculated, as well as percent standard force. Results confirm my hypotheses as all conditions showed a percent standard force reduction with the greatest decrease in the flexed wrist position. Limitations of this study involved the use of a small and homogeneous sample size with young, white, and fit PT students. Grip strength decreases with age and is critical for performing daily tasks such as driving and opening medicine bottles or jars. Clinically, it would be important to determine comparative averages of force production for different cohorts when assessing typical rates of recovery for strength regain post-surgery, as well as physical degeneration. In the clinic, it is also important to understand the reduced force capacity of maximally shortened and lengthened muscles, and particularly the limitations of muscles in positions of active insufficiency. When working with patients, it is important to keep length-tension relationships in mind to avoid putting muscles in positions of active insufficiency and maximize the muscle's force capacity. Finally, as discussed by Siebert et al., active stretching prior to isometric contractions has been shown to increase force production. It would be interesting to investigate this effect as a follow-up to these findings by performing the same test after stretching and then comparing force productions. Thank you.